My name is John Fluker, and this is my Physics 2211 Lab 4. The goal of this lab is to compare the predicted motion from glow script code to the experimental motion of a mass attached to a spring. We will also plot the change in kinetic energy, gravitational potential energy, spring potential energy, and total energy. Some key constants we need to know is the net force is equal to delta P, which is change in momentum over the change in time. The velocity update formula, which is V final equals V initial plus F net over M times delta T. And the position update formula, which is R final equals R initial plus V average delta T. Also, we need to know about the energy principle. The change in the energy of a system is equal to the work done on the system by the surroundings and the exchange of thermal energy between the system and the surroundings. We also need to know that energy can't be created or destroyed. And the change in total energy is equal to the change in kinetic energy plus the change in spring potential energy plus the change in gravitational potential energy. And since in our system there are no surrounding forces, the change in the energy system is zero. Now we look at our tracker video to look at the mass of our oscillating spring. And here it is, and you can see the X positions and the Y positions. Now we get into the initial conditions for our code. We can see the ball's mass is 0.402. The ball position, which came from the tracker videos, is negative 0.106 and negative 0.658. Gravity is 9.8. Spring constant is 6.83. And the relaxed length L naught is 0.123. Now for more glow script code, we can see that L equals ball position minus spring position. L hat equals L over magnitude of L. And S equals mag L minus L naught. Now we have our kinetic energy equation, which is 1/2 mv squared. We have our gravitational potential energy, which is mass times g times y. We have our spring potential energy, which is 1/2 ks squared. And we can see that total energy equals kinetic energy plus gravitational potential energy plus spring potential energy. And we can see we calculate our force of gravity as m times g, our force of spring as ks, and our F net as F spring plus F grav. And now we have more code, which shows our velocity update formula, our position update formula, and then our L hat S, and then our kinetic energies again, and then the change in kinetic energy, the change in potential, and gravitational potential energy. Now you can see our code here, and it's time to run it. Now here you can see the spring potential. We see our mass of our oscillating spring moving around, and then our delta K, delta U grab, delta U spring, and delta E, and our change in X, and also our change in Y. We can get our energy grabs, and then our Y position and our X position. Some possible sources of error would be that the drag force was not accounted for, which could have changed the energy and not make it exactly what it is. For your model system, is the energy principle satisfied? And it is satisfied because the total change in energy is zero, therefore the energy principle is satisfied. The sum of the kinetic energy, gravitational potential energy, and spring potential energy is always zero. Using the data attained in tracker, make two separate estimates of oscillation periods. So for our X, we have 1.425, and for our Y, we have 1.33. And the difference in the two estimates could be because of drag force and incorrect tracking of the center of mass. Thank you for watching my Physics 2211 Lab 4.